welcome everybody at this first edition of the TKI Wind op Zee live series. And online, of course, in this crazy COVID time, but I think we are getting used to meeting each other online. My name is Sophie van Hoytema and I will be your host today. The coming hour we will talk about the North Sea energy outlook, about cost reduction. We have a lot of questions, and with me in the studio here to talk about all this is Director of TKI Wind op Zee, Bob Meijer. Welcome, Bob.
Hi, Sophie. Thank you.
Bob, why do you organize the TKI Wind op Zee live series?
Well, yeah, normally in February we would have our annual matchmaking day event, and that's a full one-day event with a lot of presentations and interaction. But that's not going to happen, clearly.
No.
We were looking for alternatives, and this series of events, TKI Wind op Zee events, was a good alternative, we thought. Also to get some interaction, to share information with the innovation community.
So, can you give us a short outline of the TKI Wind op Zee program in 2021?
Yes, well, the short version is that the 2021 program, innovation program, is roughly the same as the 2020 program. Our innovation program revolves around the energy transition and how to make, the generation of vast amount of renewable energy possible on the North Sea. So it's wider than just wind op zee, offshore wind energy. It also covers, for example, floating solar as a generating technology. And we will, in the program, we try to address the hurdles in this rollout of renewable energy. And these hurdles are still cost. Costs have come down over time, but it's not enough yet. But it's also the integration of these enormous amounts of renewable power in our energy system. And the third point in our program is, the spatial planning aspects of renewable power offshore. And that's also ecology. So these are the three important elements in our program.
Oh, very good. So every TKI Wind op Zee will have a theme. And what is the theme of this edition?
Yes, well, this edition will be looking at mainly at cost reduction as a very important element in our program. We will be looking at offshore wind energy. So for this event, it will not cover, for example, floating solar, offshore floating solar. There will be other events for that that will be organized. But so we'll be looking at offshore wind energy, cost reduction, but also touch on system integration aspects.
Okay, so the theme of this first live event is cost reduction and optimization.
Absolutely.
Very good. Well, before we're going to talk more about this, we are going to take a look at a vlog of Karen Heijmen. And she will be talking to vlogster Lieke van der Plas about the North Sea energy outlook.
Hey everyone, my name is Lieke and I'm on my way to Karen Heijmen.
She is the Senior Policy Advisor at the Ministry of Economic Affairs and Climate Policy.
In this video, I will talk to her about the North Sea Energy Outlook report. Hey there! Hello! The camera is already on. Perfect, come on in. Why did you commission this report?
First of all, the expectation is that there will be a lot more offshore wind needed in the coming decades. And secondly, it takes a lot of time to realize an offshore wind park and connect it to shore. And the third reason is that we need an integrated energy system. Currently, we're working quite sectoral. We have wind, oil and gas, innovative technologies, but we need to see this as one system, and this system needs to be redesigned basically.
And what is the role of innovation?
The time frame of the NEO is 2030 to 2050, which is quite a long period. A lot can happen in this period, therefore innovation is very important to take into account. DNVGL has analyzed this and reached the conclusion that floating solar, aquatic biomass and airborne wind energy have the most potential for market readiness within this period.
So later on in this webinar we will dive into the report. Can you tell me the most striking conclusions?
Well, first of all, much more offshore wind is needed to reach the climate goals of 2050. And we need more focus on system integration because we reach the boundaries of our energy system. And construction takes a lot of time, so we need to act now.
And what's more?
Well, we need to get all this energy that is produced offshore, we need to get it onshore. So transportation will be a major challenge for the coming period. And most importantly, we need to match it with the demand. And that's crucial for creating a viable business case for offshore wind in the future.
During this webinar, we also present a study on cost reduction. How do you estimate the need of cost reduction for the future of wind energy?
Currently, offshore wind is the cheapest form of renewable energy. However, the challenge lies again in system integration and especially the conversion to hydrogen. Onshore electrolyzers are expected before 2030, but offshore electrolyzers only after 2030. They are still too expensive.
So before we go back to the studio, I would like to thank you, Karen, for the interview. And I believe you have very interesting questions for the viewers.
Yes, definitely. So what do you think is the most important challenge for offshore wind after 2030?
We would love for you to answer that question. And we can make a nice word cloud of it. Let's see if we have already some answers for that. Bob, what do you expect the challenges?
Yeah, what Karen already mentioned, of course, we'll be looking at enormous amounts of offshore wind energy for the future. And as she also mentioned, the need for innovations.
Yeah.
And of course, these could be new technologies like, for example, offshore floating solar or airborne wind energy. But still also, of course, more incremental and also breakthrough innovations for offshore wind itself, clearly.
Yeah. Can we see the word cloud? Is it possible to see what the answers of our audience are? Let's see if that's possible. Yes, 2 seconds I get. Oh, that's nice. Let's see if everybody answered that question. There we go. Looking here. Okay, spatial planning, I see. Are there some? It moves a lot, Bob.
Yeah.
But can you see some things that, of course, the things you said already, but some surprising things in this word cloud?
Yeah, I think what's also on this list is, for example, the manpower that is needed. It's a very important element. And we're rolling out all this offshore wind energy, but we also have to install and maintain it in the long term. That requires a lot of people working on offshore wind maintenance. People have to be trained. These are all technically educated people, and these are scarce these days.
Okay.
So it's an interesting
that's
aspect,
quite a challenge.
Absolutely,
yes. Yeah. Do you see one other? Shall we pick one other out of this?
Yeah, multi-use. I see also that as an important element. Of course, rolling out all this offshore wind will take up a lot of space on the North Sea, but there are also other users. There's also a food transition that we're working on. So potentially, for example, sharing space of offshore wind farms with food production could also be an option. So I think these are very important elements. And I'm also happy to see that cost is also largely printed
yes.
there. So we see that as one of the major topics and also one of the topics of this event.
Yeah, we're going to talk a bit more about that later on. First, it's time to dive deeper into the North Sea energy outlook. I'm going to give the floor, or maybe it's better to say the screen, to Martijn Duvoort of DNVGL, and they are experts in risk management and quality assurance. Martijn will give a presentation about the North Sea Energy Outlook report. So I say hi, Martijn, welcome, and go ahead, Martijn.
Excellent, thank you. Yeah, and I saw a very nice video, so perhaps I should have chosen for a video instead of a presentation. But nonetheless, I hope to guide you through the NEO. I do apologize that my slides are in Dutch. I was under the impression that this webinar was in Dutch. So I will translate, obviously, a lot of what is in the slides. I hope you can see them now. I can't see them myself on the screen. But before going to the slides, I also wanted to mention that there is a full English translation of the report available. The entire report is available both in Dutch and in English. And if you Google on North Sea Energy Outlook DNVGL, you will find at your first hit the English version of the Outlook. Now, if we go to the next slide, then as Karin already mentioned, the NEO is a full overview of the energy potential of the North Sea, both technically and economically, from 2030 to 2050. So that includes not only renewables and new technologies, but it includes also conventional oil and gas production and also storage of carbon. For this webinar, I will dive mostly into the renewable and innovation parts, and the sides of the conventional energy I will leave out. And if we then go to the next slide, then indeed, as Karin mentioned, the main conclusion of the NEO is a very positive one, because it says that offshore wind is capable of supplying almost all of the Dutch energy requirements towards the future. However, in order to do that, the entire society is in transition. We will see areas with increased electrification, for example, in industry. There's some areas may see the rise of hydrogen and the introduction of hydrogen, and the connection between all those sectors. So system integration is an essential part in order to get the puzzle right. So yes, offshore wind is capable of supplying this energy, but system integration deserves quite a bit of attention. And in fact, the ratio between molecules bringing to shore and electrons power bringing to shore is still quite unclear. So this deserves further study. If we take this to the next slide, then this will show us that in the scenarios that we analyzed, the amounts of offshore wind that we will need is huge. So the low scenario, where the Netherlands will be dependent on large-scale energy imports in 2050, still has 38 gigawatts of offshore wind, which is in total 7% of the surface area of the Dutch North Sea. And in the high wind scenario, so the scenario where we are self-sufficient as Netherlands, even 72 gigawatts will be installed of offshore wind. Now, in both cases, in situation with low energy demand, a large share of the energy demand is actually met by wind at sea. If we increase this and we look at higher demand scenarios, yes, then we will need to have go towards the 72 gigawatts of offshore wind. And again, that is energy, so that is not yet taken into account the ratio between molecules and electrons bringing this to shore. If we take this to the next slide, that is all about what are the growth ratios of the offshore wind that we need in order to reach these levels. So 7% of the total North Sea in the low scenario, and even 12% in the high scenario. And now what we'll see is actually that the growth ratios, the compound annual growth ratios for this is actually lower than what we've seen historically. So looking back in the past, then we've had, over the past decade, we had a growth ratio of 22%. If we're looking at what is projected for the next few years towards 2030, we see a growth ratio of 27%. Which is quite a scale up already. In the years thereafter, we actually can cope with a lower growth ratio of 7 to 10% for those scenarios. So whereas these 38 gigawatts or 72 gigawatts may seem quite huge amounts of offshore wind, in fact, based on an analysis of growth ratios, this is quite manageable. Now, taking that to the next slide, we look into what is then the role for innovations. And in the North Sea Energy Outlook, we looked at quite a long list of innovations. But in order for them to be really included in the assessment, we had some rather strict criteria, and that is around a TRL, minimum of 7 in 2030, and potential more than 500 megawatts. And the reasoning behind this is that if the potential for the entire North Sea would be smaller than this 500 megawatts, then from a large system perspective, why bother? If these vast amount of offshore winds are actually achievable with modest growth ratios, then why the need to look at innovations with significantly smaller potentials? Well, to answer that question directly, first of all, again, that system integration story. Offshore wind means we have to realize quite some offshore infrastructure, and we want to optimize, obviously, the use of that infrastructure. So there is a clear reason to look at innovative technologies. And predominantly those three here on the slide, they match those criteria. So floating solar, biomass, and kites, airborne wind energy, all three of them met those three criteria. And yes, this potential is really significant, and it can be in addition to the realization of offshore wind for two of them. So floating solar and biomass can both be additions to offshore wind, use the same space, use the same cable connections, use the same conversions stations. So with reasonable growth rates of 22%, we see for floating solar actually that we would be able in 2050 to realize 10 gigawatts in total, which then already includes fair assumptions around the percentage of water covered by panels and so on and so on. For airborne wind energy, kites, that is a slightly different story. That cannot coexist with standard offshore wind. So that could play a role if you look at repowering or second use of current structures. And that potential is then slightly lower. So yes, from an integration perspective and the optimization of offshore wind energy, looking at those innovative technologies makes perfect sense. There is actually a lot of research being done at the moment. So perhaps for the top sector, there are maybe quite some questions still around how to integrate this. We think that may need some further attention. Because system integration, if we go to the next slide, is actually quite a complex story. And I won't take you to this picture completely, but this is just to show that from production to end use, there are various steps into the chain, which have to do with bundling, which have to do with conversion, transport, distribution, and so on, of various commodities in various nature, either gas, either power, sometimes liquids, and so on. And there is space to optimize this for the entire system. So that's our main advice going forward to next studies. Now, if we take that to my very last slide, that is about what then are the no regrets that we have identified in our outlook. That is first and foremost, again, that we think there is a need to have an increased look at the integration of the entire system, and also what is then the optimal use of infrastructure. Part of that puzzle also is the reuse of existing oil and gas infrastructure offshore that can be used for the transportation of hydrogen. A second point here is we look very much at the Netherlands, but the Netherlands is not standing by itself, and there is various efforts around the integration of offshore infrastructure. North Sea Wind Power Hub is a consortium that looks at this, but we see a potential towards future meshed offshore grids and the existence of energy hubs. Electrolysis conversion, obviously needed if we're thinking in terms of molecules and molecular forms of energy transport. We started to look at what comes at this puzzle if you look at this. The question here obviously is electrolysis. Do you have that onshore or offshore? Which has obviously quite some infrastructure cost differences, and also some differences in the use of residual heat, for example, and the use of oxygen that you also create at electrolysis. As a last step, what I want to mention here is that there are potential lock-ins because of the limited sizes of the offshore plots. If you want to optimize system costs in terms of large-scale energy conversion, that means you also need to look at sufficiently large plots of energy production, clusters of energy production, in order to really be able to optimize that system. So the last thing I want to mention here is indeed to create an overall look on not only the production areas, but also in an integrated way with the conversions that you need for that. And I think with that, I want to conclude on this very, very short summary of the NEO. As mentioned at the start, this is available for download on the Wind at Sea webpage, but also the DNVGL webpage in both languages, UK and Dutch. And the links will also be provided by the organization. Back to the studio.
Thank you. Thank you very much, Martijn, and thank you for this very clear summary of the NEO. For everybody at home or at the office, if you have any questions, please ask them in the chat so we can try to answer them while you're still here online with us, Martijn. And Bob, do you have any questions for Martijn?
Yeah, absolutely. First of all, I would like to say that it's striking that in the past we were talking about offshore wind in isolation. And now we're talking about a full energy system. I think that's quite a different approach towards, say, the energy transition as a whole. And I think that if you look at Martijn's visualization of all these system integration elements, I think it's an enormous wide scope. So we're still looking very much at generation of renewable power, but the larger energy system is really the big question. And maybe also as a question to Martijn, what will the cost be of this system integration? If you look at all these various elements and all this infrastructure that will be included in this whole scope.
Yeah, thanks for that, Bob. Very, very good question, but I'm not sure whether it's the right question. I think what are the cost savings that you can create by looking at this in an integrated way? I think that would be very interesting to look at. In zooming out a little bit, we are providing, with the energy sector, we are providing a commodity, a product that is in demand of customers. And as any producer of any product, it may make sense to have a look at what the consumers actually want and start from that. So I think it's time here that we, as the energy sector, put the consumer in the middle, and from that position start looking at what is it that they need. And then we immediately hit the first complicated factor, and that is the consumer will not only look at energy, but the consumer is also looking at decarbonizing its feedstock. And especially for industry, that is very, very relevant to decarbonize parts of their feedstock, namely hydrogen. Hydrogen is a more feedstock source at the moment than it is an energy source for industry. And so if we start there and then look at, if we're building that system from that position on, and then look at where is conversion then most optimally placed, and from that perspective, what is the infrastructure that is then connecting this with the production locations, then I think we are looking at what are the cost savings in doing that in an integrated way and not at the total system cost. Total system costs of the entire transition are huge, and only on the distribution landscape, this already amounts to 27 billion euros, it is estimated. And on the production side and the transport side, obviously costs are also significant. I don't have a full overarching number there.
A holistic approach is required for this, that's understood. Now you mentioned, say, production of hydrogen, whether you can do this onshore or offshore. What is your vision on this?
Yeah, very good. So my vision is that indeed we will see clusters of offshore energy production that are beyond a certain scale. And beyond a certain scale, it makes sense to transport this in molecular form, because simply speaking, the transport cost itself, the cost of having a certain amount of gigawatts transported by a pipeline is much cheaper than it is by power cables. However, in converting energy to hydrogen, you obviously have quite some losses. So first, it makes sense to look at what are the power demands and how are they projected towards the future, and make sure that we are able to meet those. Also, geographically, that makes perfect sense. We see that the fast pace in the North Sea for new wind farms beyond 2030 is all more towards the northern parts of the North Sea. Main demand clusters currently are at the southern parts of the Netherlands, Rotterdam area, Zeeland area. And if we want to provide them with renewable power, then the wind farms that are Hollandse Kust and towards and around the IJmuidenver locations, it makes very much sense to connect them at least in power. So for me, I would say hydrogen is a clear, will play a clear role in connecting vast amounts of offshore wind. For the time being, I think there is still a lot of gain in connecting in power. And in the end, we will see very large hubs where there will be hydrogen conversion brought to shore, but then especially from the northern parts of the North Sea.
Much, Martijn. Well, we have two other guests that maybe you want to ask some question, I think. Bob Prinsen from Guidehouse. System integration, recent report from Guidehouse. Bob Prinsen, we have two Bobs here today. Are you in the call, Bob?
Yes, I am. Can you hear me?
Yes. Hi. There you are.
Hi.
Do you have a question?
Yes, I do. First off, thanks, Martijn, for that clear overview of the NEO. A lot of complexity that you have to tackle with the study. It's only natural that there are some limitations and simplifications required to do the analysis. There's one which I'm particularly interested in, which is you've considered annual totals. So what is the total amount of electricity that can be generated with wind in a year versus the total demand for electricity in a year? Of course, you've also looked at hydrogen, but focusing on that, you haven't looked at that mismatch over time between supply and demand. And I was wondering, do you have a view on what the impact could be if you were to consider that element in the analysis? Would that mean that you would need a lot more offshore wind than it's projected now in the study to meet the electricity demand because of the fact that you have these conversion losses if you go down the route of electricity, hydrogen, back to electricity? What's your take on that?
Yeah, very good question. Thanks, Bob. Indeed, we were not able to model this and really investigate this in the North Sea Energy Outlook. So my view on this is beyond the NEO, indeed. Couple of aspects. I think first and foremost, if we convert to hydrogen, the green hydrogen that we have produced will find its most value in the use of industry at the moment. And burning that high value hydrogen, that premium product again into gas-fired stations, burning that again, I think is a much lower value at use. So I don't think that we will actually see that, except perhaps for some strategic reserve options. I don't think that we will see that in large scale much before 2050, which is quite a while still. So that means that we need to look at system flexibility elsewhere, because we will need it. And that is also where we have done some other research. We've looked at the industry flexibility report that was also published last year in November. And there we looked at what happens if we were to curtail industrial energy consumption, power consumption, for longer periods. So what would happen if we would ask an industrial to shut down perhaps its production plant for a period of 2 weeks in a row? And then by going into the dialogue with industrials, they say, 2 weeks in a row, that's ridiculous. We're talking about half an hour flexibility. But if you then look at the value of that compared to system cost, And if you then look at, for example, the system costs of keeping dedicated gas-fired stations for those moments, for these dunkelflautes, or keeping alive a coal-fired station, perhaps, for this dunkelflaute that may occur once every 5 years. Then obviously the system costs of that route are quite high, whereas curtailing industry for a period of days to maybe a few weeks, then we're talking around millions of euros. So millions of euros versus immense system costs. So I think that indeed industrials will need to provide flexible response to the system. I think we will need to develop with one another the market products and create the right market incentives for this. And I think that it is time to understand with one another that what we now have as the most simple product traded on the market, namely a baseload product, that will be the premium product in 10, 20 years from now. Yeah, so I do think that there is a lot of flexibility on that side of the system, and at much later stage we will see the need for the use of hydrogen.
Martijn, thank you so much. But we are on a tight schedule today, so that's great, all the answers you're giving. But I have another guest for you, Bob. Can I thank you very much for asking that question?
Thank you, Martijn, for the answer.
Yes, thank you very much. We have another guest for you that in the call. It's Jörg Giegler. He's from the Top Sector Energy. And Jörg, hi, welcome.
Hi.
Hi. Can you reflect on the presentation from Martijn?
Yes, certainly I can. First of all, I think it's an excellent piece of work that has been done, thorough, looking at all the different aspects, and of course, being responsible for a hydrogen program. I'm very happy that he also addressed the issue of hydrogen. And I think that there's a sort of dilemma when we look at, on the one hand, the enormous electricity demand, and it's at the moment 20% of our energy system, but we know that it will be increasing towards 50% around 2050 or even more. And on the other hand, what Martijn already mentioned is the large demand for molecules, for example, in industry, but also in transport and maybe even in heating. So what I would be curious about is, we are now always looking at electricity from a production point of view, a production and then a demand that follows that production. Well, it's sort of that way. But what I'm curious about is, we have very ambitious targets for 2030 already. So in 10 years, we must go from about minus 20% to about minus 52%. If you spread that evenly over the different sectors, just like industry and mobility, they will be needing a lot of molecules. So what I'm curious about is, does Martijn expect that there will be a sort of a turning point, maybe earlier than after 2030, for the need of molecules, just in order to help other sectors to make sure that they reach their 2030 targets?
That's a very good question. Thanks, Jörg. And again, also this goes actually beyond the NEO. Perhaps good to mention that for the NEO, we looked at the integral infrastructure outlook of the Dutch grid companies, the EE 3050 study, and we used their scenarios for those demand projections. So our findings in the NEO are based on that. Now, if we look at indeed the period towards 2030, then that actually is a period where we haven't really spent a lot of attention from scenarios. Scenarios are often 2050 oriented, and 2030 and the period towards 2030 is something that we try to grasp from projections, looking at what is happening there now in the implementation of the Klimaatakkoord in the Netherlands. And that's an approach that we followed, for example, within the TKI, the Task Force Infrastructure Climate Agreement Industry. Now, if you look there, what the projected growth for hydrogen is, then we see actually many projects across industry in all clusters on hydrogen and related molecules. What we see is that towards 2023, 2024, in the next few years, we will see hydrogen projects of electrolyzers starting in the range of, say, 20 to 50 megawatts. And so part of the currently SMR produced hydrogen will be replaced or will see additional green hydrogen production, but always locally. And so that means that there is at this moment in time towards 2025, there will not be a hydrogen market. It's always at the demand site where it is produced, and sometimes very locally you see that hydrogen is being connected, like for example the H-Vision project in the Rotterdam area. Now, towards 2027, 2028, we will see the increase of those pilot projects from this scale 20 to 50 megawatts towards the, say, 100 megawatts, perhaps a 200, 250 megawatt scale. Now, at that moment, that is the moment where obviously the backbone of GasUnie is thought to be connecting those large industrial clusters, where we'll see central storage in the system. And so that's where you start to create a market. Very likely not an open market, but with a third-party access regime. So that will always be for a limited group of players. Part of that will be also then see the use for molecules in, for example, the transport sector. And some project of those will indeed see this scale up around the landing points of offshore wind. And so towards 2030, indeed, we will see, for example, with Noord's H2 project that Shell and partners published around the Ames location. And so that's where indeed the connection will be established.
Martijn?
But in my point of view, that won't be in the gigawatt scale.
No, well, that's perfect. That was the ending of your sentence, I think. Martijn, thank you so much. And Jörg, I hope this answer was satisfying for you.
Yes,
both
thanks.
of you, thank you very much. I'm sorry, because of the time, we need to go on, because we want to talk a lot more, and we can listen to you for hours, I think, Martijn. But let's talk a little bit more about cost reduction. And cost reduction is an important theme within your program, Bob. And that is why you asked TNO and Blix to execute research on this topic. And that brings us to our next guest online. And that they are Bernard Bulder from TNO and Imke Maassen van der Brink from Blix. Hi, welcome you both. We have some questions for you later. But first, of course, I'm going to ask you a question, Bob, because last week a report on the cost reduction potential in the offshore wind sector was launched. And the report Blix and TNO wrote is called Pathways to Potential Cost Reductions for Offshore Wind Energy. So why did TKI Wind op Zee ask for this research to be done?
Yeah, well, of course, cost reduction is a large part of our innovation program, but we would like to focus on the most promising elements within the whole range of cost reductions. So this is why we've asked TNO and Blix to study this and to pinpoint the most promising areas for cost reduction. And of course, we've seen in the previous presentations also from Martijn that we're also looking at the value, of course, of energy in the whole energy system. But still, the cost of generation are a very important element in this.
Okay, let's ask some questions to Bernard and Imke. Bernard, are you there?
Yeah.
Hello, welcome. What is the most striking result of this report?
What I think, or what we think as the most striking result is that that we still see the continuation of cost reduction, even though that originally in 2013 it was indicated that in agreement with government and industry that the wind energy would reduce in price by about approximately 40% in 2020. Well, it was even much more than that. I think it was more than 60%. But still, we see also cost reductions in the future ahead, maybe in the same order of magnitude.
Okay, well, and the report contains a kind of three-stage rocket with cost reductions. Can you indicate which structure you have chosen for the research and why?
Yeah, I think the structure was to a large extent also, I think, determined by the questions that were asked by TKI and government. And the questions were actually how determine the cost level in 2025, 2030 and beyond. And Blix and TNO chose to use a few ambitious growth scenarios for that to make estimates of these cost reductions. So we looked in 2025 to a 15 megawatt machine and in 2030 to a 20 megawatt machine, both with relatively low rotor power densities to make sure that the capacity factors of the wind turbines would be high, and that would then have an effect on the social cost for the infrastructure, so we applied those cost levels in 2025, where we looked in upscaling and we looked into incremental technology improvements, and we looked into emerging technology improvements for the period after 2030.
Okay, and the report calculates that by upscaling and applying learning curves, cost can be reduced by a third by 2030. Can you explain where the main potential cost reductions are?
Yeah, I think the main cost reduction potentials are in the balance of plant. For the wind turbine itself, we usually see that due to what we in technology quite often refer to as square cube law, it's really difficult to reduce the cost of the wind turbine per megawatt. And we would see as if you make it twice the size, in theory, it would initially go 2 to the cube, the mass would increase, which is I think a good measure for the cost, while the rotor area only increases with the square of the size, and so increasing the size of the turbine is usually not the most promising cost reduction. But we see cost reductions in the balance of plant, which is installation, which is electrical infrastructure. And I think also in operations and maintenance, we see large cost reductions if you increase the size of the wind turbine.
Okay, thank you for that, Bernard. The report, Imke, I have a question for you as well, of course. The report contains a description of 28 promising incremental innovations. So, Imke, how did you select them, and what do you consider to be the most important one, and why? Hi, Imke.
Yes, thank you. Yeah, thank you, Sophie. So let's start with how we did it. So we composed a list of approximately 100 innovations. This was based on a desk literature study and interviews we held with both internal and external experts from the offshore industry. This list of 100 innovations consists both of technical, market and supply, and finance-related innovations, which were then scored by these same experts based on their LCOE reduction potential and the efforts to achieve the LCOE reduction. This then resulted in a list of about 28 innovations, innovations of incremental, 28 incremental innovations. But I'd like to mention that during those interviews, these experts also mentioned innovations that will materialize after 2030, or more disruptive innovations, which will be discussed again during the last part of this presentation by Bernard. So these were not taken into account in the next step. And the next step was to determine the LCOE impact of these 28 incremental innovations, but only for those with highest LCOE impact and which are the best quantifiable, because that is actually not the case for all of these innovations. Some are quite difficult to quantify with an LCOE model. So what you are showing right here are these 8 innovations that were then calculated with the model, all in relation to the reference IJmuiden-Ver. And yeah, naturally, innovations that affect several cost parameters or have a major impact on the yield have a greater LCOE impact than innovations that concern, for example, only one component of the entire wind farm or of the wind turbine. So from the technical, to answer your question about which are the most important ones, we only focus on these 8, and from the technical innovations, we see that increasing the design life of the wind farm up to 40 years is the most promising innovation, with a decrease in LCOE of approximately 7.5%. The reason for this large impact is the fact that with relatively low cost increases of about 10%, we assumed the total generated yield increase is about 40%. So that has quite a large impact, of course, on the LCOE. If we look from the market and supply chain innovations, increased competition in supply chain seems to be the most promising, which can lower the LCOE with also approximately 7.5%. And this result is based on the assumption of a 2% lower capex and opex for the developer. But of course, the exact price level impact is unknown, but we do expect with the upcoming new offshore wind markets that increased competition is very likely, and the LCOE impact is also to be expected quite large.
Thank you so much, Imke. And Bernard, let's talk about these promising, disruptive or emerging innovations. How did you select them, and what do you consider to be the most important, and why, of course, also?
Yeah, I think we used the same kind of procedure as was used by Blix in the earlier work. We organized several workshops where we invited as well internal as external experts from TNO and Blix. The workshops were divided in several motives. The first one was about new wind turbine concepts, the second one about system integration, and the third one about wind farm operation and control. And each workshop was attended by somewhere between 5 and 10 experts, and they lead to and those workshops lead to a really long list of innovations. And already during the workshop and the second part of the workshop, we discussed the long list and could condense it to a more workable list of, say, 5 to 10 key innovations. And these ones are described in the report. And personally, I think that the most promising emerging technology is, I would say, the robust self-diagnosing and healing concept, which would then also, in my mind, be combined with the concept of smart /industry 4.0 technologies. And I think that one has the most promising opportunities past 2030.
Bernard, it has sometimes been calculated that the price of electricity should fall to approximately 2.5 cents per kilowatt hour, or even lower, in order to realize cost-efficient production of green hydrogen by electrification. How big do you think the chance is that we will achieve this, and if we look at the results of this report?
Yeah, well, I think it's of course not clearly to promise, but let's say in a report that we have used from the Algemene Rekenkamer 2018, it was indicated that the cost level for Hollandse Kust Zuid is in the order of 43 euros per megawatt hour. And if you then want to go down to 25 euros per megawatt hour, that would mean a cost reduction of 42%, which is, I think, quite substantial. If we then assume, and we've looked to only selecting a few innovations from the report, so we have made a conservative approximation, and then we see that for scaling up and incremental innovations, we in total see that the cost could be reduced to 65% of the level at 2020. And that's also shown in the graph. And then that excludes actually learning curve effects, and that would exclude also the emerging innovations that we assume that will occur after 2030. By taking also, I think, a conservative approach to the learning curve effect, we think that that a cost level of 25 euros per megawatt hour is achievable in 2030, and we can even indicate that it will be lower after 2030.
So much, Bernard. I have a question for you, Bob. What will happen next? How will the report be used? And what is your first response to?
Yeah, well, it's very good news, in fact. So we can continue to reduce cost. That's what the report says. And for those of you who have not read the report yet, please go to our website where you can download the report. A very interesting material. I also see that there is no, say, silver bullet or golden bullet to address this issue of cost reduction. There are many innovations are required for this. And what we will do with the report, and also with remarks that we get from readers and from this audience, is that we will, adjust our innovation program towards these more promising areas of cost reduction. So it provides us with input to focus more. I think that's very relevant. We've only so much time and so much money to spend on innovation, so we better work on the right areas. So I'm very happy with the report.
Oh, that's good news. So let's go to David de Jager. He's director from GROW. He will join us online right now. And GROW is, of course, the joint research program in offshore wind that initiates research and accelerates innovations. David, welcome. Hi. Can you hear us?
Hello.
Yeah.
Yes.
Yeah,
I can
thank
hear
you. David, do you have any questions for Bernard or for Imke?
Yes, I do. Maybe for Imke, you indicated that a lot can be gained from international competition, increased international competition. If I look back at the last decade, I basically say, well, that has done its job already significantly. And I would say that today's market in offshore wind is very, very competitive. So where do you see room for really more competition? Are we already continuously driving really close to the lowest prices around? So where do you see still opportunities to squeeze out some euros per megawatt hour?
Is Imke still there?
She's muted.
Well, that's always, we learn to mute and unmute a lot in this time.
Exactly. I was not able to unmute myself. But thank you, David. That's really a good question. And of course, what I just presented to you, it's not just my personal opinion, it's also the outcome of all of these interviews that we've held. So I can only respond to my view and what we see. Of course, there are a lot of upcoming offshore markets, not just in Europe, but also in Asia and in other parts of the world. And in lots of these countries, there is already a supply chain for the onshore wind market. So that's where we see there can come more competition from those suppliers which already offer services to the onshore wind market, and now can also do it for the offshore market in the future. Of course, this is not something that will develop within a couple of years, but it is something we should keep in mind on the longer term until 2030. But yeah, like I said, that's my personal observation. Yeah.
But are you, for instance, thinking of the Chinese entering the European market with maybe even lower turbines costs and even maybe lower installation costs?
Not just like specifically Chinese, but Asian in general, indeed, but also from other upcoming offshore wind markets in the southern part of America, South America, but also the Baltics, for example. There are definitely other markets that could enter the current offshore wind market supply chain.
And maybe if I am A question that hints a little bit to Bob.
I saw Sophie.
Hi, David. Oh, we would love to talk for hours about this, but I think David, I'm so sorry. I think we have to go on. Bob, I'm not looking at you. Let's.
Yeah,
Yeah.
we only
I
got
have a question for Bob, basically.
It's a question for Bob, David. Okay, very good.
Now, maybe you say we will use this as a starting point for our innovation program. If I look at the options, then there are little options for operation and maintenance. And operation and maintenance makes about 30% of the LCOE, of the cost. So is there a blind spot in Innovation Society for operation and maintenance? And maybe that's something for you.
My answer to that is no. Of course, operations and maintenance is still a very important element. And also given, say, the longer lifetimes, this becomes more relevant, I would say. And so if you're looking at a 40-year lifespan of an offshore wind farm, most of the cost will go into operations and maintenance eventually. So that's a very important element. And thanks for raising this, by the way. We're drawing to the closure of this first TKI Wind op Zee live event. But we also want to have your opinion about potential areas for cost reduction. So what I'd like to do is to raise a poll question where you can fill in your most promising areas of cost reduction. Can we start the poll for that?
Yes, we can.
And of course, while we're looking at the poll being started, I can also give you some news about the winners of the recent tender that was organized. We see there very interesting projects. You can read more about the results of the MOI tender later on. But the CIMOX and the RoboDoc projects, I want to congratulate them with their results. And of course, also these, or part of these projects are also working on operations and maintenance. So the poll question, I see the results coming in. Well, lifetime extension, that really jumps out. So that's a key element that came also out of the report from TNO and Blix as an important area. And of course, this raises new questions in a way. So if you say lifetime extension, that's easily said. Maybe say permits that can last for 40 years or longer. But we're also looking then at more fatigue-resistant materials that we need to develop. And so lifetime extension in itself also triggers a whole new range of innovations that are required to make that happen. But it's a very important element, clearly, in cost reduction. Looking at also at other areas, new materials. Clearly, I already mentioned that if you want to extend lifetime, then you will have to look at new materials, but also maybe lighter materials. So these are also important elements in cost reduction. There are many good ideas on this slide, and we'll definitely take the input on board. I'd also like to mention that during this webinar, it may be difficult to interact, but of course, we're always open for your input. And input about our program, about also the subsidy mechanisms from the top sector energy and the TKIs. So if you have information about this or questions, please contact us. And we have a special email address open for that. We'll show that later on. Where you can reflect on our multi-annual mission-oriented innovation program targeting, say, offshore renewable energy. So with that, I think we're going to a close now for the event. And personally, I'd like to thank you very much for all the input. But Sophie?
Yes, of course. Yeah. Well, it's the time's nearly up. We're wrapping things up, and of course, we'll show a video first. Oh yes, this is what we're going to show. Well, and Bob, of course, you already said you would love to have some feedback and people that talk with you. So if you have any solution or if you're looking for cooperation partners, please use the matchmaking form on the email address you see over there, www.tki/windopzee.eu, or if you want to send feedback on the program, if you have any question, always contact us at the other MMIP1 email address. So, Bob, as you were saying, all the questions will be looked at and, of course, will be answered at the TKI Wind op Zee. Do you have 10 seconds to do a brief review on the past hour?
Yeah, we've seen a lot of information from also the North Sea Energy Outlook at the wider energy system on the cost reduction report. I think it's now time to also orient ourselves towards the update of the innovation program, so to get all your feedback and also to look forward to the next events.
Yes. And the theme of the next event will be?
Yeah, it will in fact be system integration. So we've already seen that this is maybe the next most important area of innovation.
Well, I think that's it. Maybe it's nice. We have a final question for you. If you like to give your appreciation for this first edition of TKI Wind op Zee Live, this a question will be asked right now. And for you, all of our guests, Bob, of course, thank you very much for being here. All of our guests, Bernard, Imke, Bob, Jörg, David, Martijn, thank you very much. And everybody at home, thank you very much for joining this first edition of the TKI Wind op Zee Live series. And I hope to see you next time on that is the 2nd of March. We'll have a next with a theme system integration. And it would be great if you could register for each edition. We would love to do that. So thank you. See you next time. Goodbye.